Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss how to implement Max Heap in Java. So friends, in our previous tutorial we actually discussed that binary heaps are of basically two types. One is the min binary heap and other is the max binary heap. So here you can see a max heap is a complete binary tree in which each node value is greater than or equal to the values of its children. So here, if we take any particular node, let's say 9, so its value will be always greater than or equal to the values of its children. So here you can see 9 is greater than 3 and 6. So this property should hold true for each and every node of this max binary heap. So if we take an example of node having value as 3, then 3 is greater than 2 and 1. And similarly, if we take an example of 6, then 6 is greater than 5 and 4. And also in a binary tree, the last level has the leaf nodes, so therefore the property holds true for them as well. Also friends, in a max heap, you can see that the maximum value is always at the top, which we also call as the root of the binary tree. So here in the max heap, the root always has the maximum value. And if we represent this max heap in a form of an array, then it would look something like this. That as this max heap has 7 elements, we will first create an array of length 8, because the first element we always keep it as empty, and we start insertion from the index 1. We also discussed in our previous tutorial that how we actually insert this value inside an heap. So we go level by level from left to right. So at level 1 we have only the root node, which is 9. So 9 is placed at an index 1. Similarly, at level 2 we have 3 and 6. So 3 is placed at index 2 and 6 is placed at index 3. And at level 3 we have 4 nodes, 2, 1, 5 and 4. So 2 is placed at index 4, 1 is placed at index 5, 5 is placed at index 6 and 4 is placed at index 7. So friends, here you can see the maximum value of this binary tree is at the root, which is 9. And if we represent this max heap in an array, then here you can see at index 1 we will always get the maximum value. Moving ahead. So friends, here you can see the code for the implementation of the max priority queue. So this is the initial implementation, and there are many more methods which we will discuss in our upcoming tutorials. And here you can see this max priority queue is nothing but our max heap, where it has the integer array which we discussed in our previous slide. So we give it as a name of heap, and we actually store the size of this max priority queue in the integer variable n. So friends, here you can see in the main method, the first step we do is we basically create an instance of max priority queue, and to its constructor we are actually passing the capacity, that how many elements this max priority queue will hold. So here you can see in the constructor the value which we are passing is nothing but the capacity of the max priority queue. So this is nothing but the initial capacity of the max priority queue. So when this line gets executed, the call reaches to this point, and we know that we have passed the value as 3, so the capacity is 3. Now as we have this instance variable which is an integer array by name heap, and the integer variable n which holds the size of this max priority queue. And also friends, here you can see that this integer array can be any generic type array, but for the simplicity of understanding I am using here as an integer array. So here in the constructor, the first step we do is we actually create an array having length as capacity plus 1. So it would look something like this. Now capacity is 3 and we have initialized this array with a length of capacity plus 1, which is 4. So why we actually do capacity plus 1 is because we discussed in our previous tutorial that the first element in an array we always keep it as empty. So we actually don't use the index 0, we always keep it as empty, and we place our elements starting from index 1. So here you can see, as we are not using this 0th index, now the array can hold a capacity of 3. So therefore we are initializing this integer array with a length of capacity plus 1. Moving ahead, now as we have initialized this max priority queue here, the initial value of n would be 0 because there are no elements currently into this heap. So n is 0. And also friends, here we have provided two methods. One is the isEmpty method, which returns a boolean value which tells that whether priority queue is empty or not. So here you can see, if the value of n is equal to 0, then we know that there are no elements into this heap and max priority queue is empty. So we simply return true if value of n is 0, or else we return false. And the second method we provide is size. We simply return the value of n. So here if we call the size method, it will print 0 because currently the value of n is 0. And then if we simply call isEmpty method to check whether priority queue is empty or not, it simply return true because n is equal to 0. So friends, this is a basic and initial implementation of a max priority queue. There are more other methods which we will discuss in our upcoming tutorial. So the only understanding we need to see is that a max priority queue basically implemented through an array which we give here name as heap, and we simply create an integer value n which keeps the track of the number of elements currently into this heap array. So friends, this was a demonstration of these few methods. Now let's go to Eclipse and see the working of this code.